Very good afternoon to all. Myself Nikhil Gupta. I am assistant professor in a mechanical engineering department in IIMT College of Engineering. Today I am here to give my video lecture in a very interesting topic and very useful topic that is directly used in industry. The topic name is CPM PERT. It's a very realistic topic. Now these are the outline of my project. These are the outline of my PPT. One is the define the project. Second one is the what is the CPM. Third one is the important terms used in CPM oblique PERT. The next one is the problem discussion of CPM. Next one is the importance of CPM. Next one is the characteristics of CPM. And next is the what is the PERT. And last one is the basic difference between and use of CPM oblique PERT. Now, before starting the CPM, first of all, I would like to discuss some measure. What is the project? Basically, a project can be defined as a set of large number of activities, that are performed in a certain sequence to determine the logically or technologically to complete in a specified time to meet the standard performance. Means we can, in other words, we can say any project which have any time frame and completion time frame, that is known as a project. From many years, two approaches that have been proven be very useful for planning, scheduling, controlling of the project. One is the CPM. The name of CPM is the, as see here, critical path method. Second one is the PERT. The name of PERT is project evaluation and review technique. Now next, what is CPM? Basically, CPM, known as critical path method, is a mathematical algorithm for scheduling a set of project activities. In other words, we can say that the critical path method or CPM is the sequence of scheduled activities that determine the duration of any kind of project. Critical path method is also used to find the critical and non-critical activities in the project. In CPM, critical path is the longest path. In other words, we can say it's the longest path in a network from the starting event to end event and define the critical time required to complete the project. To understand what is CPM, I'm taking a example. The example is a project consists of 5 different paths in a network. The duration of these different paths is 10 weeks. Means first path is 10 week completion time. Second one take is 13 week. Third one is taken 15 week. Next one is 20 week and 25 week respectively. In this project, we can say 25 is the longest duration of completion time, and that means we can say in this given here in this project, 25 weeks are the maximum path to finish the work, so that 25 weeks are the critical path. Means that path which take longest duration is known as the critical path. Next example, this is the graphical view, layout view, which we can say this is the starting end. This is the task 1, which take 3 days. This is the task 2, which take 2 days. This is the task 1, the task 3, 4 days. Next task F is taken 1 day, and this is the finishing event. If we can take another path, the path task 1 means task B taken 4 days, task C taken 3 days, and this is the finishing point. If we follow this path, the completion time is 3, 2, 4, 1, total is equal to 10 days. And if we follow the second path, it take 4 days plus 3 days is equal to 7 days. We can say 10 days means the first route is taken 10 days to completion of this project, and second route is taken 7 days. Means 10 days is the longest duration, means it is the critical path, and the length of this overall path is 10 days. This is also the example in which this is the starting event. Event 1, it take 15 days. Activity 8 take 25 days. Event 2, follow the activity D. 10 days. Event 4, follow the activity F, 15 days. Event 5, follow the activities I, 10 days and endpoint. If we follow this route, means starting end, first and fourth, sixth and final. Means activity B taken 15 days, activity E taken 5 days, activity Z taken 10 days, activity J taken 5 days, and then. And this is the third route. Activity C taken 20 days, activity H taken 20 days, and the finishing route. This means we can say these are the three different paths. The route here, this path number 1, path number 2, path number 3. Path 1 will take 25 days, 10 days, 15 days, 10 days is equal to 60 days. Path number 2 take 15 days, 5 days, 10 days, 5 days, means this path. Total 35 days. And path number 3 take 20 days and 20 days is equal to 40 days. In we can say, we are looking here, the red line is showing the longest path because it is taking the 60 days, and 60 days is the highest duration of the path. Means this is the critical path, critical length, and the length of this project is the 60 days. Now, before understand to CPM, these are some important terms which are directly used in CPM. One is the activity. What is the activity? An activity is an identifiable job that has beginning and then end. Example, we can say construction of wall, construction of roofing, etc. To denote this activity, this is the method to denote the activity. This is the event 1, event 2, and this is the activity. What is the event? Now, an event, also called the node, is beginning or end of an activity. An event does not consume any time, manpower, or material resources. It represents by the specific point of circle. Means in this activity, it follows the two events. This is the event 1 here, starting event, and this is the event 2. This is the end event. Means to represent this activity, we need two events. One is the starting event, and second one is the end event. This event did not kill any time. What is the critical path? In any network, it is the longest path connecting the starting and end event. Now, what is the earliest starting time? Earliest starting time it is the time at which an event is accepted to be completed at the earliest. It is denoted by the TE. Here, this is the activity A, this is the activity B. This is the event number 1, 2, and 3. Means we can say in the starting event, T is equal to 0. In second one, 0 plus 10 is equal to 10. 10 plus 12 is equal to 22. These are the earliest event. 0 for this activity. For B activity, 10 is the earliest event. 10, and this is the finishing event. Latest finish time, it is the time by which an event should be completed so that the project completion will not be delayed, and it is denoted by the TL. Here, this is the activity A, and this is the activity B. First of all, we calculate the earliest starting time TE. For this, T is equal to 0. And 23 and 3. But latest finish time is calculated from the end side. Means 23 is the TE for this event. This TE is equal to the TL for this whole activity. TL is equal to T is equal to 23. And now for this event, 23 minus this duration of time. 23 minus 15 is equal to 8. This is the TL for this activity, and for this event. Say similar, 8 minus the duration of activity, 8. 8 minus 8 is equal to 0. This is the TL for this event or this activity. Next, select time. It is the difference between the latest finish time to the earliest starting time. Means slack is equal to TL minus TE. Note, slack always 0 at a critical path. If any critical path, there slack will be always 0. Means TL is equal to TE. Critical event, the event with zero slack time are known as critical event. Similar critical activity, the path which follow the zero total float are known as critical activity. Now, what is the total float? It is the maximum time by which the completion of activity can be delayed without affecting the project completion time. We can say this is the marginal time, but it should be limited. If any marginal time delay the activity, we cannot say this is the total float. Total float always calculated by this equation. TL is equal, total float is equal to TL, latest finish time, minus earliest starting time, TL minus TE minus duration of the activity. Here, in this example, we calculate TL. This is the TE for 0, 10, 12. This is TE 0, 10, 22. This is the activity time, 10 minute activity A, 12 minute activity B. If we calculate the total float for this activity, means activity B. So what is the total float? TL minus T. TL of event 3 means that TL will taken 22 minus T of event 22 minus 10 means TL of this, and T of event number 2 minus duration of activity means 12. TL minus TE minus 12 is equal to 0. This is the total float. Next, what is the preceding activity? For a given activity, the activity that occur immediately before is known as preceding activity. Here, there are two activity, activity A and activity B. For activity B, always activity A is the preceding activity. In second thing, succeeding activity. For a given activity, the activity that follow immediately after is known as succeeding activity. Here, activity A and activity B. For this activity, means activity A, always activity B is the succeeding activity. In other words, we can say the previous activity is known as preceding activity, and the next activity is known as succeeding activity. What is the concurrent activity? The activity that can be carried out concurrently are called as concurrent activity. Digging of well and excavation of foundation are concurrent activity, means this is activity 1, and activity 1 is follow activity C and B. So means C and B are both are parallel to each other, and these are the concurrent activity. What is dummy activity? Basically, it is the imaginary activity in a network. It is an imaginary activity in a network. It does not consume time because it is not realistic activity. It is only used to complete the path of the project, like this. This is the real activity because it taken some time, and this one is the dummy activity because it does not kill any time. Activity B is the dummy activity. This is used only to complete the network. For example, how to understand a heat exchanger. A heat exchanger consists following tasks periodically on the heat exchange in a refinery. Calculate the network diagram for activity, identify the critical path, and what is the length of this overall project. These are the activity, we can say task. Activity A, B, C, D, E, F, G, H, I, and J. Similar, these are the procedures. Means there is no procedure of activity B, means A is the starting activity, and A is the procedure of B, and B, B, and B. These means C, D, E. B is the procedure of C, D, and E. Similar, E, F, and G is the immediate procedure of C and C. H is directly procedure of F and G. Similar, I follow the D, E, H, and J follow the I activity. And that this is the duration of these activity, means A activity taken 14 days, B taken 22 days, C taken 10 days, D taken 16 days, E taken 12 days, F taken 10 days, similar like this, and J taken 16 days. Now we draw the critical path. First we draw the activity A. It take 14 days and follow the event number 1 and event number 2. Now activity B, it take the 22 days and follow by the event number 3. Activity C take 10 days and followed by 3, event number 3. Similar, activity it take total 6 days followed by event number 4, or we can say activity C. Next, activity D taken 16 days and follow the activity B. Here, activity H follow the activity F and activity G. And because here we use the dummy activity because G activity is finished here and for F activity is forwarding. So where to complete this network we use dummy activity, means D1. 0 means it does not kill any time, so we use 0. Similar, in 7 means activity E is completed here. To complete this network we use dummy activity number 2, means D2. It also take time 0. Similar, I activity follow the activity D and activity H, and it take 24 days, and at J follow by activity I, and it take the 16 days. This is the network of all the tasks given in the project. Now we calculate the critical path and other parameters. Like there are 3 routes. One is activity A, activity B, activity C, activity G, D1, H, I, J, and second one is the path number 2, activity A, B, C, G, H, I, J. Activity route number 3 means path number 3, A, B, D, I, J, and the path number 4, A, P, E, D2, I, J. If we calculate the time of these all the routes, path number 1 followed by the event number 1, 2, 3, 4, 5, 6, 8, 9, 10 means it take 100 days. Similar, path number 2 follow the event 1, 2, 3, 4, 6, 8, 9, 10 means it take 104 days. Path number 3 follow the event 1, 2, 3, 8, 9, 10. Total duration 8. These are the path 1, 2, 3, and 4. In this path, we are looking here. It take 100 days, it take 104 days, it take 92 days, it take 88 days. We already discussed that critical path follow the highest duration of time. Means 104 days means path number 2 is the critical path. Since 1, 2, 3, 4, 6, 8, 9, 10 has the maximum duration and it have total 104 days. It is the length of the project. In this network, we are looking here, marking by the red lines, means activity A means 1, 2, 3, 4, 6, 8, 9, 10. This is the critical path and it take 104 days to complete the project. Now, what is the use of CPM? Basically, CPM used in all the industries and all the fields. First is research. It is also used in research and development project, means R&D project. It is also used to maintenance of any equipment or overhauling of the tools. It also used in construction sites like building, bridges and dams also. It is used to setting up new industries or new plant or new project. It is also used to planning and launching of new product. CPM also used to design of plant, machines and system also. Shifting the manufacturing location to another location means if we shift to plant in first location to second location, this also very helpful. It is overall used to control the production of a large soap. The importance of critical path in network, it analyzes and break down the project in terms of specific activity or event. It determines the independence and sequence of the specific activities and prepare a network. It also assigns the estimation of time, costing, or both of all the activities of the network. Now, what is PERT? Basically, PERT is known as Program Evaluation and Review Technique. is a method used to examine the task in a scheduling and determine the critical path variation. It analyzes the time required to complete each task, and it associates dependencies to determine the minimum time to complete the project. A PERT is used to following three estimation of each activity to find the various time. One is the optimistic time defined by TE. Second one is the pessimistic time defined by TP, and most likely time. What is the optimistic time? The optimistic time is the shortest possible time in which an activity can be completed in ideal condition. Means minimum time taken by the activity is known as optimistic time. Second one is the pessimistic time. It is the maximum possible time that it would to take the complete an activity under the worst condition. If there is a scenario worst condition, then it take the long highest time. This is known as pessimistic time. In other words, we can say the smallest time is known as optimistic time, and highest time taken by the project is the pessimistic time. In between optimistic and pessimistic, the average time is known as most likely in time. Means we can say it lie between optimistic and pessimistic time estimation, and it is the time in which an activity can be completed under the ideal or normal condition. The expected time is always denoted by T and calculated by this is standard equation. Means optimistic plus pessimistic, optimistic plus pessimistic, or most likely time. Means TO plus 4TM plus TP divided by 6 is calculated in this equation. We can calculate the expected time is T. This T is used in network analysis. And what is the characteristics of PERT? PERT survey base of obtaining the important fact for implementing the decision making. It forms the basis for all the planning of activities. PERT help management in deciding the best possible resources utilization method. PERT take advantage by using time network analysis technique. Similar, PERT present the structure for reporting the information. It also helps to the management to identify the essential element for the completion of the project within a given duration. Now, this is last one. What is the difference between PERT and CPM? PERT is a technique of project management which is used to manage uncertain. That means time is not known. Where time is not known, we use the PERT activity. Means PERT chart. See, in other way, a CPM is the technique for project management which is used to manage only a certain, means time is already defined. Second, it is the event oriented technique, which means that network is constructed on the basis of event. It is a technique which means that network is constructed on the basis of activity. We can say this is the event oriented method, and this one is the activity oriented method. Now, it is the probabilistic model, and it is the deterministic model. It majorly focus on a time, as meeting time target or estimation of project completion is more important. In other word, here CPM it majorly focus on time. Cost trade off, as minimizing cost is more important. And in here in PERT, it is appropriate for high precision time estimation, where time is the necessity, very high precise value. Then we use a PERT. In CPM. In CPM, it is appropriate for reasonable time estimation. It has no repetitive nature of job here, and in CPM, it has repetitive in nature form. Next, the PERT. There is no chance of crashing, as there is no certainty of time. But in CPM, there may be crashing because of certain time boundation. Means there is no possibility of project crashing in PERT because we calculate three different times: optimistic, pessimistic, and most likely time. But in CPM, there is a possibility to crashing of project because the delay of the project. It does not use any dummy activity. But we already discussed CPM follow the dummy activities. In PERT, it is suitable for project which required research and development and it is suitable for construction of project. We can say on construction site we use CPM, on realistic project we use PERT. Okay, thank you very much.